Hello, students. Hello, those of you who are working on your own. It's Miss Hernandez. You are working on your chemistry packet on the second 6 weeks. Today, we have moved 4.4, section 4.4, law of definite proportions, and we moved it to Wednesday. I know I had planned on doing it Tuesday, but I went ahead and I switched it. Okay. So today we're doing 4.4, law of definite proportions, and it's the same information that you see here, except you're going to see it in a PowerPoint on Pear Deck. And I have my fifth period students who are working with me today, and they are going to be helping me out do our presentation today. So, section 4.4, the information, all of it comes from ck12.org. The section is called Law of Definite Proportions. And if you are a baker or if you like to cook things, you need to make sure that your portions of each ingredient is correct, right? You don't want to put too much salt because it's going to ruin how good it tastes. You don't want to put too much of one ingredient or too little of one ingredient because it might change what you're cooking. Think about that when we're talking about today's topic because it is very, very similar. Okay? Guys, are you ready? All right. I'm sure they're ready. All right, so here we have our introduction, and it's all about electricity and voltage. And we have three pictures. One is you have a lady cooking or preparing a meal. You have a gentleman in picture number 2 working on looks like he's working on some wiring, and you can see that I don't know if that's an outlet or if that's a switch. And then the third picture, which is a picture that I see all the time in my classroom, several cell phones charging. Okay. And the number one rule when it comes to asking to charge your cell phone in my class, if you come to class on time, you can charge your phone. Okay. If you are late, that's a big, big pet peeve of mine. If you are late, don't even ask to charge your phone because you're already late. Just get to work and get started. Okay. Don't ask. So those of you guys, if ever we get back into school, you need to charge your cell phone in my class. Make sure you get to class on time. All right. All right. So here we have our introduction. Who's going to read for me today? Who's going to help me out? Irvin or Yalexia or Oscar? Who's going to help me out? One of those three students. Who's available, guys?
I'll do it.
Thank you, Irvin.
We use electricity for many purposes, from cooking to powering our television to charging our cell phones. Wherever we travel in the United States, we want electricity to be able, but we also want, although we usually don't think about it, is for the electricity supply to be the same wherever we go. We want the same voltage, 110 volts for the US to come from the outlets to whatever we plug in. Okay. If the voltage is less, and the system will not work. If it is more, the equipment will be damaged. We want the specific amount of voltage, no more and no less.
Thank you, Irvin. And you should probably turn off that TV so you can focus or mute it. So anytime you're working with electricity and you go to plug in whatever device you're trying to turn on, whether it's a toaster, whether it's a cell phone, whether it's a lamp, you want the voltage to be enough electricity to supply whatever it is you're trying to turn on. And in the United States, you need 110 volts of electricity to be coming out through that outlet. Okay. And this is really, really important because if you don't have enough, if your wiring is old, and that usually means that you're not having enough electricity being supplied because the wiring can't handle it. Okay. Maybe it's some old wiring and it can't handle it. So your voltage is low. That will definitely affect the device you're trying to turn on, right? If you're trying to charge your cell phone, it might not charge at all. If you're plugging in a lamp or a toaster, it might work, but it not might be working to it's 100%. It might be at about 60 or 80%, and it might take longer to cook, or it might not be as bright as it should be. The thing that we've seen a lot in movies is when Americans go traveling to like the old world, like kind of like Europe, countries that have buildings that have been around for hundreds and hundreds of years, right? Well, not hundreds and hundreds, but a couple hundred. Um, and I don't know if you guys ever seen a movie where a girl goes to plug in her hair dryer or her curling iron or her flat iron, and all of a sudden the building goes black. So what did you do to cause that blackout? What did that person do to cause the blackout? Well, they overloaded the system. Maybe the wiring, like I said, is old and you are pulling too much energy, and all of a sudden you have broken, a fuse in the breaker, and all of a sudden everything goes out. It happens. It happens. We've seen it in the movies, and I think I have some friends who've experienced it in real life. Okay, but either way, we've all experienced something regarding our voltage. If you've ever gone to the dollar store and bought a $5 charger, you're like, ooh, $5 for an iPhone charger and it's 10 feet long. I'm going to get it. And then you get home, and then what happens? You plug it in and it doesn't work. Why? Because maybe that wire is not supplying enough energy to properly charge your device. Okay. And you always want the correct voltage, because if you have too much voltage, you can you can basically bust whatever it is that, or break whatever it is that you're plugging in. And if it's a cell phone, it can cost you a pretty penny. Some cell phones right now are running, $1,800 right now. Okay. So whatever voltage is coming through, you always want to make sure that it is the correct voltage, and that the reason it's coming up for today's topic is because formulas. If you have the incorrect amount of elements, then you're changing your formula. And an example is water, right? Everybody knows the formula for water, H2O. So that means you have 2 hydrogens and 2 oxygens. And if you change the amount of any of the atoms or elements, you're changing your compound. Okay. And an example is, well, if you have 2 hydrogens, but you change your oxygens to 2, well, that's hydrogen peroxide. That's a different substance altogether with different properties. And if you change your hydrogens to 3 and your oxygens to 1, that's a totally different compound. That's hydronium. Different properties, different substances that will react differently than what you're supposed to be working with. Okay. So be careful, guys. And keep that in mind when we're talking about today's topic. Now, here we go with today's content. It is the law of definite proportions. Now, there was a law regarding mass and conserving it that you've probably been studying in the past. And I'm going to just switch to Jamboard real quick. Not this one. Here, this picture right here. If you know the law of conservation of mass, which some of you might have heard in another science class, you know that it states that mass cannot be created or destroyed in a chemical reaction. It only gets rearranged. So whatever it is you're starting with, your reactants should equal by mass the same as your product. So if you started with 10 kilograms of reactant, your product should end up at around 10 kilograms. Okay. That is the law of conservation of mass. How much mass you start with should equal how much you end with. So that law is where this law came from. The discovery that mass has always conserved in chemical reactions was soon followed by the law of definite proportions. And this law states that a given chemical compound always contains the same elements in the exact same proportions, okay? So if we're going back to the example of water, if I have the same elements, hydrogen and oxygen, I need to make sure that the amount, proportions is a fancy word for saying an amount, right? An amount of something, right? And in this case, for water, you have to have 2 hydrogens, 1 oxygen. If not, it's a different compound. Okay? So remember that, because they might ask you that in the next slide. As an example, any sample of pure water will contain 11.19% of hydrogen and 88.81% of oxygen by mass. So that's the percent of each element by mass for this compound of water. Now, can I reverse engineer that information and get the formula that I need? 2 hydrogens and 1 oxygen? Of course I can. It's math. Anything can be reversed. So if we go to Jamboard, and I'm going to go to Jamboard, so come back to the Google Meet real quick. And if I have hydrogen, I can mathematically prove that this information is going to give me the correct formula. Okay? And watch. Check this out. So the first thing that I'm going to be doing is I need to find the mass of hydrogen and oxygen. So I'm going to go to my periodic table. I already have it up. It is for hydrogen, element 1, the mass is 1.008, which if you round it is 1.001. So what I'm going to do is I'm going to divide my percent by the mass, which we said is 1. Oh my God, what is that? 1.01. Okay, now I'm going to find the mass of oxygen and do the same thing. Oxygen is 15.99, and if we round that, it's basically 16. So we're going to divide oxygen by 16 grams. Okay, and if you do the math, which I have my handy dandy calculator, not texting anybody. As you can see, I have my calculator up. I'm going to take 11.19 and divide that by the mass of hydrogen, 1.01. So I get this answer, 11.079. I'm just going to round that, okay? 11.08. That's what I rounded it to. Now, I'm going to next divide the percent for oxygen by its mass, 88.81. Then divide that by 16, 5.55. All right, now that I have that information, the only thing left to do is to divide my numbers by the smallest answer. And between these two, oxygen's answer is smaller. So I'm going to divide both of them by 5.55. Okay. And they're not S's, they're 5s. Anytime you divide the same number by the same number, you get 1. Okay. Now, if you divide 11.08 divided by 5.55, look at that answer. Oops. 1.99. If you were to round that, you would end up with 2. So, if I were to compare, so this is what I end up with. Is that the correct formula for water? Does water have 2 hydrogens and 1 oxygen? Sure it does. Everywhere around the world, it doesn't matter where you get your water from, that amount will not change. It does not matter where the sample of water comes from or how it was prepared. Its composition, like that of every other compound, is fixed. So if you get your water sample from Pakistan, from China, from Australia, from South America, from Antarctica, all the way to Greenland and anywhere in between, the formula and the composition of water will always be the same. 11% hydrogen, 88% oxygen, 2 hydrogens, and 1 oxygen everywhere around the world. Okay? All right, you have your first question. You have your first question here. The law of definite proportion states that water always contains the same elements in the exact same proportions by mass. True or false? All right, start answering, guys. True or false? Okay, if you're getting kicked out and you're coming back in and you left the Pear Deck, let me put there's the link in case you need it again. All right, so is that a true statement or a false statement? Does the law of definite proportion state that water always contains the same elements in the exact same proportions or amounts, right? Proportions just means how many there are. Okay? True or false? If you are not in the Pear Deck, you are to be posting in the chat. And I don't see anything right now in the chat about true or false. Okay, I only have 8 students in the Pear Deck. I have total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students. So I should have 3 students answering in the chat whether they think it's true or false. 3 students should be answering in the chat. All 8 should be answering in Pear Deck, the ones that are logged in. All right. Irvin, did you answer the question in the Pear Deck? Mario, Melissa, Arlette, Efrain, Jose. If you're not answering in the Pear Deck, you should be answering in the chat. All right, I got 5 responses. Let's check it out. 4 people say it's true. 1 person says it's false. Oh, my 4 has gone up to 5. 5 students have said that is a true statement. 1 person says it's false. All right, let's go back. And it says here that a given chemical compound, so they changed it, right? They said water always contains the same elements in the exact same proportions by mass. That is a true statement. If you pick true, every single person who picked true, all 5 students here, are correct. Good job, guys. Really, really good job. Excellent. Any questions on this slide? Let's talk about a second example. Very good, Alexia. Now let's talk about a second example known as carbon dioxide. Carbon dioxide. So everybody has heard of carbon dioxide. Another example is carbon dioxide. This is a gas produced from a variety of reactions, often by burning materials. So guys, if you've ever helped your dad gather some mesquite or just plain wood of any kind, and you burned it to make your carne asado on Sunday or on Saturday or on Friday, you are creating, every single time you burn wood, you're creating carbon dioxide. That is a chemical reaction. The structure of the gas consists, now this is how many there are of each atom. There are 2 atoms, there are 2 elements in this compound. Carbon, which you have 1 atom, and oxygen, which you have 2 atoms. Okay? Carbon dioxide production is of interest in many areas, from the amount we breathe out to the amount of gas produced by burning wood or fossil fuels. I don't know if any of you guys have ever seen somebody talking to their plants. Nobody has ever seen anybody talking to their plants? Guilty. When I was a kid, my grandma, Melissa, seen people talk to plants? I don't know about you, Melissa, but me, my grandma would always talk to her plants. She would talk, yeah, Alexia, you too. She would say, "Ay, qué bonitas flores me has, que has floreado." And, she would talk to them and say, "Ay, crezca muy grande," como, she would talk to them like they were their best friends. That your grandma would do that too. My grandma would do that too. And so me now, I have my own plants. I have my plants that I have outside, and I'm like, oh, and I do find myself talking to them sometimes. So I'm like, oh my god, I'm going crazy like my grandma, and look at me talking to plants. And at first I was like, why am I talking? Why should I be talking to my plants? And the more I thought about it, I said, well, what is what is something that all plants need? Carbon dioxide is food for plants. So every time that I'm talking to the plant and I'm like, oh, he looks sad. And I'm like, oh God, it looks sad. I need to put water. That's usually what I tell my plants. And I'm like, I'm sorry, I'm sorry I haven't given you water. And every time I do, I'm giving them some of that carbon dioxide that they need to produce that oxygen that we need, right? Plants are very important to humans because plants feed us and we feed them. Carbon dioxide is used by plants to make oxygen for us, just like we use oxygen to make carbon dioxide. Okay? Did you ever think about that? So don't ever think that your grandma was crazy when she was talking to her plants. Just like everything, plants are alive too. So talking to them not only feeds them, but it might help them in the growing process. It doesn't hurt, right? It doesn't hurt, except the fact that if somebody else sees you talking to your plant, they might think you're crazy, like we thought of our grandmas. All right. Now, this is a really important statement, okay? This is the most important statement in this paragraph, so listen carefully. By knowing the exact composition of carbon dioxide, okay? So they're talking about the correct formula for carbon dioxide. If you know the correct formula for carbon dioxide, you can make predictions, or we can make predictions as to the effects of different chemical processes. So, what does that mean? That just means if you have the correct formula and you're using carbon dioxide in a reaction, you can predict what will get produced. Okay? If your formula is incorrect and you're trying to figure out what's going to get produced, you're going to come out with a wrong answer. Okay? Why? Because everything needs to balance. Okay? And if you have 3 carbons, 1 oxygen, which is not the formula for carbon dioxide, and you're trying to make something out of that formula, it's going to give you a tough time, because anytime you do reactions, you have to balance them. And if you don't have the correct number of elements in your compound, you're going to have a tough time. Your answer is going to be wrong, right? And if you're going to be like, Miss, I got something different than everybody else. And I'm going to be like, okay, well, let me look at your reaction. And I'll be like, your formula's wrong. That's why you're getting something different. Okay? That's how come you can't balance. That's what I'm going to be telling you. So anytime we get to the part in this class where we start to learn how to write formulas, make sure you're paying close attention, because that is a very important skill for this class that you're going to need for the rest of the year, all the way to June. All right? So you have to make sure you have the correct formulas so that you can make predictions and figure out what products are going to come out of certain chemical reactions. All right? This one's an easy one. You guys better get this one right. How many carbon atoms are there in a molecule of carbon dioxide? Excuse me. How many oxygen atoms are there in a molecule of carbon dioxide? All right? Give me your answer in the pear deck, okay? Tell me, how many carbons do you see in this picture? How many oxygens do you see in this picture? And this one's a real easy question, guys. Really, really easy. Okay, only one person. Okay, 2 people have responded in the pear deck. I need more than 2 people. Let's go. I need at least 5 or 6 students answering. And this is a really easy question. Try it out. The question says, how many carbon atoms, how many oxygen atoms are there in a molecule of carbon dioxide? What do you think? What is the correct answer for this one? Only 2 people have answered. Guys, how many do you have of carbon? How many do you have of oxygen? Tell me. Come on. This is a really easy question, and we're almost done with our presentation, but I'm not going to move on until I get 5 or 6 answers here. Irvin, did you answer the question? Gabby, Kaylee, Efrain. America, have you answered the question? All right, 3 people have answered. I need 3 more answers. 4 people have answered. Come on, guys. How many atoms do I have of carbon? How many atoms do I have of oxygen in this compound or in this molecule? Come on. Hello. Hello out there. Are you there? Melissa says that there are 2 oxygens and 1 carbon. And you know what, Melissa? That is the correct answer. Very good. All 5 students who answered in the Pear Deck got it right. There are 2 oxygen atoms and 1 carbon atom. Very, very good. That's a good ending to today's lecture. I call that a good day. All right, let's summarize the topic for today, the section. And you only have 1 major bullet point. The law of definite proportion states that a given chemical compound always contains the same elements in the same proportions by mass. Yay. All right, so your review questions. These are the ones that you're going to be answering today. State the law of definite proportions. Number 2, will the composition of water molecules vary depending on its source? And then number 3, why is this law important? Okay, you should easily be able to do number 1 and number 2. If you need extra help, well, you know I'll be around.